Assalamu alaikum. We will start the second lecture today. Yesterday we discussed about requirement. What is the difference between requirement and requirement engineering? And then we primarily discussed the requirement story and what happens if requirement goes wrong for a system. And today we will start our lecture with system engineering. System engineering, when we discuss about system engineering, so normally we are talking about a simple computer based system. We are talking about a computer based system. Now if you look into the general system requirements, normally general system we say the PC system or the simple system. So we say this is a general system, and there will be definitely some requirement associated with general systems. So there is a close relationship between software and more general system requirement. Software, whenever we create for a particular, so for example, I have a system of 32-bit architecture. So you are very well aware of 32-bit or 64-bit architecture systems. So if I have a 32-bit architecture system, so definitely when I create a software for that particular system, so that software will be actually a 32-bit software as well. If the architecture is 64-bit, then obviously the software which we are going to create will be 64-bit architecture software. So there is a close relationship between software and general system requirement. Normally, when we categorize computer systems, yeah, or we can say computer-based systems, so they are categorized or they are divided into two categories or broader categories. The first one is user configured system, and the second one is custom system. Now, the difference between user configured system and custom system is when a purchaser puts together a system from existing software products, we call that particular system as a user configured system. Here we call the system as a software system. We are considering the system as a software system where a purchaser puts together a system from existing software product. So we will say this is a user configured system. Like for example, existing software, existing application software is Microsoft Excel or Microsoft Access, and you want to use Excel as a, for example, in examination system, we use the Excel as a DMC printer software, and DMC print for the purpose of printing the DMC. So we say this is a user configured system in which we have configured or we have used existing software product so that it can work according to our requirements. Whereas the custom systems are where a customer produces a set of requirements. Normally, custom systems are specific for a particular customer or a group of particular customer. So we call that system as a custom system. In user configured system, we are not talking about specific requirements. We are talking about general requirements, or generally requirements are made and systems are created based on the existing systems, existing software products. But in custom systems, a customer produces a set of requirements. A customer will give you a set of requirements for a particular hardware or software system, and the software engineer, which we call contractor, develops and deliver that particular system. So this type of the system, we will call it as a custom system. So one is the user configured system, the other one is a custom system. In one, there are no requirements given to you by the customer. They are the general requirements. They are the existing software products, and you just combine together, you group together the existing software to create a new software or to utilize that existing software in a new way. But in custom systems, the requirements are given to you by the customer, and those requirements are grouped together, and a new software is created, and that new software will be that new software will be used by the customer, and it will be delivered by the developer of the system. Normally we call it as a software engineer. Now there are different classes of computer custom systems. Primarily basically we talk about custom systems because in custom systems we are having requirements coming out of the customer. So we will talk about custom systems. So classes of custom systems are when we divide the custom systems, so these are the following classes of custom systems. The first one is information system, the second one is embedded system, and the third one is command and control system. In information system, primarily concerned with processing information which is held in some particular database. If you are retrieving some information or you are updating some information in the database, or you are retrieving or you are inserting information to a database, so you will call that particular system as a information system. Like for example, your LMS, learning management system. So your learning management system is a kind of information system. This is first class of custom system. The second one is sorry. The second one is embedded system. So embedded system where systems where software is used as a controller in broader hardware system. The simple examples are your microwaves. The biochip is having my biochip is not a right example. Your automatic machines at home, your digital refrigerators at home. These all are what these are the embedded systems example. The third one is command and control system, which is a combination of information system and embedded system, where special purpose computers provide information which is collected and stored and used to make decisions. So we call those particular system as command and control system. Command and control systems are actually the amalgamation, the combination of information system. It means that in command and control system, you have the software side, you have the database, as well as your software is controlling your hardware. So we combine together both of them, and we say this type of the custom system is called as command and control systems. Then we have for further classification and examples. We have in classes of custom systems. I have given you example of information system. Your learning management system is an information system. The softwares used at the bank are information systems, and decision support systems or knowledge management system, or your PayPal or Amazon transactions or Daraz.pk transactions. These all are what they are, the information systems. The second one is embedded system. Normally in telecom sector, they are used smart cards or your missiles and satellite guided missiles and automated satellites. They are the good examples of embedded system. Computer networking devices are embedded system. Software executes on the hardware. Software controls the hardware. So we will call that particular system as a embedded system. So these are the few examples of information system and embedded systems. Okay, now we have discussed the classes of the systems. Now we will come towards the emergent properties of the system. The word emergent by itself defines a particular thing, that is something is coming out of another thing. So we will say that something is emerging now. So this emergent properties are the system properties which are as a whole represents the properties of the system and only emerge, only come out. Here emerge means they only come out once all of its individual systems have been integrated. Like for example, you are creating a system in which you have three submodules, module 1, module 2, and module 3. When you combine module 1 with module 2, when they are combined to grouped together, you will get another a new property defined by combining these two subsystems. After the combination of the two subsystems, when a new property is defined, when a new property is created, or when a new property comes out, so you will say this is emergent property of the system. Normally we call these properties as non-functional requirements of the system. They are also discussed in software in basic course of the software engineering, and where we call it the non-functional requirement. The common examples of emergent properties are the reliability of the system, and maintainability of the system, performance of the system, usability of the system, security, and last but not least, that is safety. These all are what they are, the emergent properties of the system, and they are not the services provided by the system. They are actually what they are, the emergent properties of the system, and they come out when the subsystems are integrated in one way or the other way. So we call it as emergent properties of the system. Now we will discuss the system engineering process. It is very much similar to the waterfall model of the software engineering, but there is a difference between the system engineering process. This is SEP process as well. In SAP system engineering process, first of all, we gather requirements of the system. System requirement engineering process is executed at first. The requirements for the system as a whole are established and written to be understandable to all stakeholders. Normally, they are written in the form of SRS document. In system engineering process, the first step is gathering the requirements and documenting those particular requirements in the form of SRS document or in the form of visual document. Then the second step in system engineering process is your architectural design. In architectural design, the system is decomposed into subparts or subsystems, and the system is divided, or we can say the system is divided into manageable subparts. So the design which we are creating or the step we are following in system engineering process is called as architectural design. Then we perform the requirement partitioning. Once the system is divided into subsystems and requirement are already obtained, then we can assign requirements to those subsystems. This process is known as or called as requirement partitioning. And then we apply software requirement engineering. A more detailed system requirements are derived. Yeah, more detailed system requirements are derived for the system software. This whole process or this whole procedure is called as software system engineering process, starting with basic requirements of the system, creating architectural design of the system, then assigning requirements to the architectural design in which we have got subsystems, and then refinement of the requirements. Normally, that is the software requirement engineering methodology or process. So this collective effort is called system engineering process. Further, we do what we create the subsystem development. Once requirements are refined in this previous slide, once requirements are refined here, after the partitioning of the requirement, then we go towards the subsystem development, because requirements are already partitioned, requirements are already assigned to the subsystems. Now we are in a position to create that particular subsystem, and then we are in a position to apply system integration. System integration is that whatever you have whatever you have decomposed, now you have to recompose those subsystems to group together so that they can be called as a system. So this process is called as system integration, in which we combine all the subsystems created individually so that they can become a system. Overall a system, we call it overall a system. And then last but not least, we perform system validation, that whether the system is according to the requirements of the customer. This whole process, starting from the requirement engineering, ending at the system validation, this whole engineering process is called as system engineering process. Then we have some observations about requirement engineering. Requirement engineering, as I've discussed, there is no definite or defined formula or formalism that requirements will be always done in a particular way. There is no definite way or perfect way defined to extract requirements. The one and only basic reason is the demographic behavior or the demographic studies available for people or humans. So requirement engineering is not necessarily a sequential process. This is not sequential process. Whatever you have, whatever you know, you can apply on XYZ customer and you can extract requirements from that particular customer. Requirement engineering is a set of activities that continue throughout the development process. This is a set of activity not necessarily performed in a particular process of order. You can apply it in any order in order to extract requirement from the customer. The second observation about requirement engineering is the problem statement will be imperfect. Normally, the problems are coming out of the real world, and there is maximum possibility that the problems will contain inaccuracies and inconsistencies. Now, what is inaccuracy? Inaccuracy is data is not coming to me in the form in which it was required. And inconsistency is, for example, I wanted from the stakeholders that information should be coming in this way. The other stakeholder demands the information in another way. So there is inconsistency. The system will respond to both stakeholders, and the resultant value will be an inconsistent value for that particular service. So we say the system is performing in inconsistent way. Normally it omit some information. Omit means that it will avoid some information. So this is another observation about requirement engineering. Detailed analysis can reduce the risk that these will cause serious problem. When you perform detailed requirement analysis or detailed system analysis, so we can avoid, or at least we can limit inaccuracies or inconsistency, and we can work on why not to omit some informations present in the system. But that risk can never be reduced to. We have already talked about in software engineering that risk cannot be made or cannot be equal to zero. Yes, we can reduce the risk, but we cannot eliminate the risk from the system from occurring in the system. So this is another problem, that is a problem statement will be imperfect. Imperfect means the problem defined by the customer is normally having inaccuracies or inconsistencies, especially in the case of larger systems in which we have got more than one customer. If more than one customer is involved, so there will be possibility that inaccuracies and inconsistencies will occur within the system and within the or in understanding of the problem statement. Perfecting a specification may not be cost effective. Another issue or another observation about requirement engineering: requirement analysis has a cost. For different projects, the cost benefit balance will be definitely different. If we take project to project, so the project to project demographic study, requirement, type of the requirement, nature of the application, this all will affect cost of the software. So if you want to have perfection in your requirement specification, so if you want to achieve perfection in requirement specification, so this may not be as much cost effective as it should be, because software engineering always tend to believe that whatever we create in software engineering, whatever the software product is created, it is always created in a cost effective manner. Problem statement should never be treated as fixed. Every time, whenever we define a problem, whenever there are requirements, so we cannot deal those requirements as a final requirements given by the customer. And again, this is a question arises that is it necessary that all the time the requirements will not be fixed? Other than waterfall model, any model you are using in the development of the software will not have fixed requirements, and it will not be treated as a fixed requirement, especially in the case of defining the problem. So change is there, change is inevitable. Inevitable means that change is unavoidable. Whenever the time progresses, definitely there will be change in requirement, and that we should plan about that particular change, and there should be a way of incorporating changes periodically. You should be allowing your system to accept change with the passage of time. So these are some observations about requirement engineering. Then we will talk about importance of requirement engineering. So there are some problem associated to define importance of requirement engineering. That is increased reliance on software. In our daily life, we have discussed in already, this is in discussion in the prerequisite course of this course, that is software engineering, that more and more systems are software controlled. For example, your cars are having softwares, your dishwashers are now software controlled, your cell phones are software controlled, your web applications or web services are software controlled. The first problem is that you are increasingly relying on the use of the software. This is why requirement engineering is important. This is why extracting proper requirement from the customer is important. Second one is software now the biggest cost element for mission critical system. We have discussed critical systems. So in critical or mission critical systems, the one of the biggest cost element or the more expenditure is utilized on creation of the software. This is the second problem, and wastage on failed project. There is an example of 1997 GAO report which says that $145 billion over 6 years on software that was never delivered. So this much cost can be lost if there is a failed project, and that wastage will be another problem associated with requirement engineering. That is why we say that give importance to requirement engineering. When the requirements are correct, the failure chances will be less, and if the requirements are wrong, the failure chances will be at higher side, and higher consequences of failure. Like for example, if you are losing $145 billion or 500 million payload, for example, or Intel Pentium bug, which was present in the Intel Pentium systems that lost at almost $475 million. That was because of system was going towards failure, and this is the high consequence of failure. This is the problem associated with not extracting proper requirements from the customer. So this clarify us that why requirement engineering is of importance to us. Key factor about the key factors: certification cost in is another genuine case, that there should be certification cost. 40% of software budget is spent on testing. This is obvious. Whenever you create a critical software, the testing cost will always be at higher side. That is certification cost. And rework from defect removal, if you want to remove bugs and defects or the elements of failure present in the software, so that rework will be obviously that will play obviously a key role, and that is 60 to 80% of software budget cost. Is normally 60 to 80% budget is spent over the rework, because rework requires understanding of the existing system and then bringing out the changes in the existing system, so that rework can be done and remove defects are removed. And obviously there is another key factor, that is requirements have the tendency to change over the time. So this is why we say requirement engineering is important in our execution or creating a particular software and avoiding a software to go towards failure. What do requirement engineers do? Normally, requirement engineer is an agent of, normally or generally we say that requirement engineer is an agent of change. He must do identify, or he must do, or he must perform. First thing is identification of the problem within the system or creating a new opportunity. We can have two things to create a system, or either identify problem in the existing system or create an opportunity so that we can have a new system. So these two possibilities are the is the responsibility of the requirement engineer. Then he has to identify which problem needs to be solved. Normally he is defining a domain for that particular problem, that this problem lies in that particular domain. This is called identifying problem boundaries. Where is the problem? You have to understand the context or problem domain. You have to identify that the problem, for example, in calculator, in our example of the calculator, addition, multiplication, and subtraction, this is my problem domain, that is arithmetic calculator. In this, I have to understand a context, where is the problem. So understanding that particular context means that the problem is at arithmetic operation. Now this is location or locating the problem. Why does it need solving? Identify stakeholder goal. Stakeholder told me that you have to add two numbers if two numbers are similar in addition. So you have to add one to it by default. Now the problem, you have identified the problem. Now you are trying to provide a solution to that problem in terms of the stakeholder requirement or whatever the stakeholder wants from you. How might a software system help? So you have to create scenarios that after providing the solution, the software system will act like this. So you have to show that system in the form of scenarios. When does it need solving? Identify development constraint. If it is not being solved, you have to identify why it is not being solved and why it needs to be, or how it can be solved, using keeping in mind of development constraints of the system. What might prevent us solving it? So I identify the feasibility, whether this requirement can be accommodated. If it is accommodated, what are the risks involved in making this requirement as a part of this particular system. So this is the responsibility of the requirement engineer, that identify problem, locate the problem, whose problem is it, how it need to be solved, how much a software system will be helped after this problem is provided, and when it does, or when it is required to provide solution, keeping in mind the constraints of the system, and what might prevent us solving it, keeping in mind feasibility of that particular requirement and the risk associated with the problem. After you do perform this all, you are an expert in that particular problem domain. So we have studied key points in this chapter. What are the key points? What we studied in this chapter? We have discussed requirement. We have discussed requirement engineering. We have discussed requirement problems, that if requirements go wrong, what will be the effect of the wrong requirements over the system. Then we have discussed system engineering, and then we have discussed system engineering process, and then we talked about requirement document. That is, the requirements are documented in a particular document. Normally we call it SRS document or vision document. And then we have talked about requirement document should include like similar like the SRS, in which we have got an overview or an introduction about the system, glossary, statement of functional requirement, non-functional requirement, and the operational constraints. So this is a chapter all about this is a chapter all about requirement and requirement engineering generally. And then we have overall discussed the requirement engineering process. And then we have discussed the importance of requirement engineering. We have seen some observation about requirement engineering, and we have discussed what requirement engineers do. So thank you very much. This is the end of this chapter. And if you have got any questions, you can post in your WhatsApp group already created. Thank you very much.